Good afternoon, students.
Good afternoon, sir.
Good afternoon.
Afternoon, sir.
Yeah, good afternoon. Actually, today career examination going on. So many classes are conducting the career examination. So that's classroom is not available. So that's why again I have to today I have to share this material. So that's why I'm not able to take live class. Most of the classrooms are occupied. Students, did you receive any information from the university regarding reopening? Any communication did you receive? Anyone reply? Yeah.
So we have received yesterday,
Hmm.
so we are not sure about it right now.
Mummy,
So we
our
are
voice
waiting for the.
break.
Sir, we received, but we are not sure is it from SRM or just fake
Hmm.
one. We don't know.
Okay, okay.
So because there is no steel or some signature sort of thing.
Hmm. Yes. Actually, that Tamil Nadu government declared the date for reopening of the college date. But now, right now, the situation, all the parents are against that reopening date. So that's why the date of reopening, I think, I thought it has will be extended one more month. I don't know exactly. But previously, under one order, November 16th, all colleges are should be reopened in November 16 onwards. But so many parents are against that this order. That's why I don't know whether it is extended or not. This is the situation, current situation. Okay, first I'll start the class.
So you can wait for 2 more minutes, sir. Like maybe people would be coming.
Okay, okay, ma. I got to wait. Okay, but only 32 only joined. Time now 1:12. Okay, shall I start it? Okay.
Okay, sir.
Okay, so this is the last topic of Unit 4. Actually, little bit I will explain. So I was explaining the previous class. So now again elaborately I will explain. Okay, so two-way classification means two-factor influence here. For example, men and workers, season and sales, that kind of factors influencing that statement. Actually, your null hypothesis, there is no significant difference between the row factor and column factor. So that is your null hypothesis. Unity hypothesis, there is a significant difference between the row factor and column factor. So previously, one-way classification, your null hypothesis, there is no significant difference between the column factor only. Okay, so we have some 5 columns and 4 columns. So you have to find out is there any significant difference between the columns. But here, so we have to find out any difference between the row factor and column factor. So that is your null hypothesis, alternative hypothesis. Accordingly, you can set up alternative hypothesis. Okay, so immediately the first column you consider as x1, second column you consider as x2. Then we have to how many columns are given in the data. You can consider all the columns. So you can put the total for all the columns, sum of x1, sum of x2, and sum of x. Okay. Similarly, here also we consider the row factor also. Okay. So therefore, that row factor you are taking as y1, y2. How many rows are given in the data? You consider all the rows. So accordingly, you put the row total here, sigma y2 and sigma y. Okay. So in that manner you can prepare one table. Then after that, so you can square all the column values x1 squared, x2 squared, etc. How many columns are given there? All the column you have to square that one. Then you have to put total for all the columns. Okay. So from initially we need this table. Then only we can consider all the we can find out all the calculation. So therefore here column x1 x2 similarly y1 y2 y3. So that is we have to consider here both you should be consider row as well as column. So from initial you can prepare this table. After that you can find out the following procedure. In step number 1, so you have to find out total number of observations. So this is you can simply you can calculate how many rows are given, how many columns are given in the data. You multiply these two things, row into column, you are getting sorry. So it's a number of observations that is you have to find in step number 1. And step number 2, you should find out total number of so sum of the total number of observation. Okay, so therefore some values are given in the data, row and column. You should sorry. So you have to find out sum of all the values given in the data that you have to find out in step number 2. Okay. Sorry. Actually, T is nothing but not total number of observation. Yeah, that's okay. T you can find out any one of the way. You can find out each every value. Here some observations. This one, this one, this one. You can add that way. Also, you are putting sigma x1, sigma x2, or sigma y1, sigma y, sigma y. Okay, you can either you can find out this column total or this row total that will represent the T. Okay, so that will represent the T. That is you have to calculate in step number 2. Okay, which means that you can find out sum of all the values given in the data. So that is represents capital T. Next one, step 3, you should find out your correction factor CF. That is nothing but T squared by N. Already you in step number 2 you get it T, and step number 1 you get it N. That how to find out here T squared by N. That is your correction factor. And step number 4, you have to find out total squares. So total sum of squares sigma x1 squared. So in that table we already you get it. Sigma x1 square, sigma x2 square, that things. So that how to find out step number 4, that value subtracted from the correction factor CF. Okay, that is you have to follow step number 4. And step number 5, so sum of squares between the columns. Okay, sum of squares between the column, that is represents sum of x1 square, that value you have to find out here. This sum of x1, that you have to squaring that one. Then how many observations given in the column, in the first column, n1. Okay, sum of x2, that is the second column, you can squaring all the values. Sum of x2, you can squaring that by n2, how many observation given in the second column. So in that manner you can find out all the columns, that value subtracted from the correction factor. So therefore n1 n2 were number of entries in each columns. Okay, so up to step number 5, same as ANOVA 1, that is one-way classification, ANOVA table for one-way classification. So therefore step number 1 to up to step number 5 both are same. Okay, for one-way classification as well as way classification. So here we can add one more thing, row factor also you are considering. That's why you have to step number 6, you have to find out sum of squares between the rows. Okay, so sum of squares between the rows. Similarly, sum of you can consider here in the table. In that table we have sum of y1 and sum of y2, then sum of y1 here. Already you are getting this row wise total, sum of y1, sum of y2. So how many entries given in the rows, how many entries given in the second row, how many entries given in the third row, you have to consider here. Okay, so sum of squares between the rows, sum of y1 whole squared by m1, sum of y2 whole squared by m2. So all the we consider and divided by number of entries given in each and every row. So m1 represents first row, how many observations are there. M2 represents how many observations in the second row. In that manner you can find out all the rows that will be subtracted from the correction factor. So m1 m2 is nothing but number of entries in each rows. So okay, so this step only newly added two-way classification. So up step 5, that is same, one way and two way. So now you are newly added step number 6. Next one, step number 7, sum of squares of the error, that is nothing but total sum of squares minus sum of squares between the column minus sum of squares between the rows. So in that you have to find out in step number 6. Now in step number 7 we have to prepare our ANOVA table. Okay, so ANOVA table, so look at here, the first column source of variation. Here we can consider column factor as well as row factor, between columns, between rows and error, that we have to get. But now one-way classification we are considering between columns and error only, but here we are including rows also. So sum of squares is nothing SSC, already in step number that value SSC you are getting from step number 5, that that value you can place it here. And SSR step number 6 you are getting that value, that you have to place here, SSR sum of squares between rows. And SSC you are getting in step number 6, that you have to place in here, SSE. Then corresponding degrees of freedom between columns C minus 1. So now C represents number of columns given in the data. Here SSR number of rows in the given the data, that is R minus 1. And error degrees of freedom is R minus 1, C minus 1. So therefore after adding this one you are getting total sum of squares. That's why TSS is nothing but already you are getting SSC, SSR and TSS. Okay, then step number 4 TSS, step number 3, and step number 4 SSC, and step number 4. So if you want SSC now, then you have to write TSS minus SSR minus SSC. Clear? Actually in that step, SSC how to get TSS, that is total sum of squares between the columns, sum of squares the rows. So therefore if you are adding that, you have to shift everything now, you are getting total sum of squares, that is your place. So but we don't know about this this row, that is for your observation only. Suppose the question asking write down the ANOVA table for two-way classification, that situation you are considering this. So therefore this is nothing but you are getting total sum of squares. After adding that one, you are getting the degrees of freedom is RC minus 1. Okay, so now sum of squares over that corresponding degrees of freedom over. Next, you have to find out mean square. Mean square, you already know the sum of square that divided by corresponding degrees of freedom. That is sum of squares between row that corresponding degrees of freedom, and error, sum of squares of the error that corresponding degrees of freedom. So therefore, so now we can find out your F ratio. So here we are considering the F ratio for column factor as well as row factor. So therefore, first you are considering column and error. Which one is greater, that you have to place in the numerator. A smaller, you have to place in the denominator. So in that way, you can find out the first F ratio. Second F ratio for the row factor. So you are considering row and error. Which one is placed in numerator? Which one is greater, that you are placed in the numerator, and smaller placed in the denominator. To get it this one, this formula. So therefore, you should find out 2 ratio as well as column factor and row factor. So which one accordingly you can write your degrees of freedom numerator. Suppose if facing MSc in a, what is the degrees of freedom? R minus 1, C minus 1, that is your numerator degrees of freedom. So placed in the denominator MSc in a, that you have to denominator degrees of freedom is between column is C minus 1. So in that manner you can find out your here degrees of freedom. So already you know conclusion. So how to write one? If you're first, you have to find out between columns your calculated value less than the table value, we accepted H0. If your calculated value greater than the table value, you can reject your H0. Similarly, we can find out the conclusion for between the row factor. So the calculated value less than the table value, accept H0. Calculated value greater than the we can reject our null hypothesis. So this procedure is clear, Pa?
Yes, sir.
Yeah. Now we look at one problem for two-way classification. Okay, well, there's sales of 4 salesmen in 3 seasons. Okay, A, B, C, D. We are considered 4 salesmen A, B, C, D, and then that salesman sailed in 3 season, summer, winter, monsoon are stated here. So therefore, salesman and C. Okay, so 2 factors are influenced here. Salesman according to their sales in that respective season, summer season, winter season. So therefore, in that column clearly 2 factor influence. That is your row factor is season, your column factor is that is salesman. Therefore, carry out an analysis of variance, which means that is there any significant difference between the salesman and their sales in the different season? So that is the question. Okay, so carry out of analysis of variance means, is there any significant difference between the salesman and their sales with respect to the season? So that's why we have to carry out analysis of variance means. So is there any significant difference between the sales according their sales in the different season? Okay, so therefore 2 factors influence. So that is coming for two-way classification. So in this program, okay. So first beginning, there is no significant difference between the salesman and between the seasons. So alternative hypothesis, there is a significant difference between the salesman and between the seasons. Okay. Okay. So from that already I explained. So here we have the large number of data, 45, 40, 38 and 30. So we have to calculate most of the calculation and adding and subtracting, that kind of the things, algebraic calculation we have to do. So that's why we have to simplify the data, so that if you are simplified now, easily we can prepare the table and the calculation also very easier. So that's why here most of values are multiples of 40. So therefore we have to fix one common origin, that each and every value subtracted from the common origin. The data you are get it in the simplified manner. after that your calculation also very easily you can do it, that calculation. Okay, so that's why you have to suppose if you are considering the same value, that's also no problem. Okay, so finally your answer will be this, whether you have to consider common origin and each and every value separated from the common origin, or you are considering same data, that is no problem, you are getting the same answer. So keep this. Okay, so that point. So are you getting the point, Pa?
Yes, sir.
Okay. So now in that problem, actually, most of the values are having multiples of 40. So that's why I'm fixing the origin 40. Therefore, each and every values are separated from the common origin 14. So therefore, look at your first column. 5 minus 14, that becomes 5. 43 minus 14, that becomes 3. 39 minus 14, that becomes minus 1. Okay, so look at your second one. 40 minus 40, 0. 41 minus 14, 1. 39 minus 14, minus 1. Okay, and 38, look at your third column. 38 minus 14, minus 2. 35 minus 14, plus 5. And 41 minus 14, plus 1. And 37 minus 14, minus 3. And 38 minus 14, minus 2. And 41 minus 14, that becomes plus 1. Okay, so in that manner, now the data is simplified. Okay, so 5 3 minus 1 0 1 minus 1 minus 2 5 1 minus 3 minus 2 1. So this column you are considering x1 x2 x3. So therefore 4 columns given in the data and number of rows here 3 rows. So that you have to considering, this is row wise you are considering y1 y2 y3, column wise you are considering the variables x1 x2 x3 x4. Now you can put the total column wise as well as row wise. So 5 minus 2 minus 3, that becomes 0. First you have to put row wise total. So sum of y1 is sum of y2, that becomes 7. Sum of y3 becomes 7. Okay, similarly you can find out sum of x1 7, sum of x2 0, and sum of x3, sum of x4 equal to minus 4. Then you have to immediately you can squaring the columns. Each and every value you can square it. X1 square, x2 square, x3 square, and x4 square. So you have to find sum of x1 square, sum of x2 square, x3 square, and sum of x4 square. Okay, in that manner you can prepare the data. Okay, so first we can follow the steps. Step number 1, first you have to find out capital N. Capital N is nothing but total number of observations given in the data. You can counting one by one, 1 2 3, or you can use this formula, rows into columns. So how many rows are there? That is 3 rows. And how many columns are there? 4 columns. So therefore 4, that is 3 rows and 4 columns. That is this is not correct. So 3 columns are how many rows? We have the 3 rows. And columns, how many columns are there? 4 columns. Okay, so therefore 4 into 3 12. So you can count one by one, you are getting the same total, or if you are using row into column, you can, that's the you are getting the same total. Okay, next is step number 2, you have to find out total seven plus 1 8, 8 minus 1 7. You can adding you can add one that, or either you are getting, so this one represents total number of observations. Okay, so now you can adding this 3, well, this column only 0 7 and 0 7, or either you are putting row wise total, that is also you are getting the same. So therefore that is nothing but total number of observations in the data 7. Either the way you can adding either row wise or column wise, there is no problem. Next you have to find out your correction factor, that is nothing but t squared by n. So therefore 7 squared by, that is 12, 4.083. And step number 4, you have to find squares, that is nothing but this sum of x1 square, sum of x2 square, this sum of x3 square, this sum of x4 square, that value minus correction factor, 35 plus 30, you are getting 76.917. And step number 5, sum of squares between the columns. So therefore these are the values, sum of x1, that value you have to squaring, sum of x1 whole square, number of entries given in the column 3 entries. Okay, similarly you can sum of x2 whole square, how many entries are there? 3 entries. Therefore, sum of x2 whole square. This is sum of x3. How many entries are there? That is 3. Each column we have three entries. That is not mandatory. So each and every column we have different number of observation, but in that column all observations are same entries. So therefore, this is sum of x1 whole square. 3 entries are there. Sum of x2 value 0. That's why that is 0. Sum of x3 4 are there. Sum of x4 is minus 4. So that is 3 entries are there. After computing that one, you are getting step. Sum of squares between column is this answer. And step number 6, sum of squares between the row. Okay. So between the row, you are considering row total, sum of y1 whole square, sum of y2. So now we are considering the row total also. So that is sum of y1. How many entries are there? 1, 2, 3, 4. So sum of y1 whole square divided by 4. And sum of y2 is 7. That value you have to square. Are in the row 4 entries. And sum of y3 is this one, that you have to divided by the number of given entries in that row. In that manner, you can find out your step number 6. Sum of y1 whole squared by n1, sum of y2 whole squared by n2, n3. So therefore, each and every rows we have 4 entries are there. So this is 0, this is 0. So therefore, you are getting that result 8.167. And step number 6, sum of square between the error. That is nothing but total sum of squares. Already you are getting. This is step number 7, not 6. Okay. So total sum of squares you are getting in step number 4. This is step number 5. This is step number 6. So after getting that result, you are getting. This is nothing but sum of error. So now all the requirements are over for preparing that analysis of variance. That means ANOVA table. That is you have to do in the step number 7. Okay. Okay. So now look at here in this table. Okay. Source of variance between column, between rows, and the error. Sum of squares between column is now you are getting in the step number 4. This step number 5 you are getting sum of squares, and step number 6 you are getting that result. Total sum of squares that becomes you get it in the step number 3. Okay. So corresponding degrees of freedom C minus 1, number of columns given in the data 4 minus 1 given in data, that becomes 3, 3 minus 1 2, and that R minus 1 is C minus 1, R minus 2 C minus 1 3. So 2 into 3 that becomes 6. Okay. So therefore you can add it total 6 plus 2 8, 8 plus 3 11. Okay. That you have to get it the same here. R into C. So how many rows and column? 12. 12 minus 1, 11. So that is equal to, you are getting that. If you are adding this one or if we are using that one, both are getting that same. Next one, mean square, corresponding column, rows and error. So mean square between the column, that value, that corresponding degrees of freedom, 22.917 divided by 3. And the mean square between the rows, then sum of squares between the rows divided by the column, and mean square error, sum of squares of error, that corresponding degrees of freedom, you are getting that one. So now we look at your, find out your F ratio. So therefore, first you have to consider the F ratio for column and the F ratio for row. Okay. So column means you can consider comparing column and the error. So which one is 7.639? This is 7.6388. So therefore, that column only, MSC only, that is a greater one, that you have to place in the numerator. So next one, that one is smaller, that you have to place in the denominator. Anything. So therefore, that becomes 1. Okay. Similarly, you can consider row factor. So which one is greater? You have to place in the numerator 7.63. Which one is small? That you have to place in the denominator. Therefore, you are getting 1.87. So therefore, now your level of signification is 5% you are fixing. So therefore, now here 7.639 represents MSC, that corresponding degrees of freedom is 3, and the denominator you are placed in error degrees of freedom is 6. So therefore, look at your F table at the degrees of freedom 3, 6, that becomes 4.76. Already you know how to the table value in a table. Okay. So next one, find already a ratio over. So now 7.638 placed in the numerator. So that corresponding degrees of freedom is error degrees of freedom is 6, and 4.0835, that is the row factor, that you have to place in the denominator, because this one is smaller by comparingly the error value. So therefore, the degrees of freedom is 2. Look at your F table. The 6,2 degrees of freedom, that your value is 9.33. Okay. So therefore, here now comparing this is your calculated value, this is your table value. So if your calculated value less than the table value, now you can accept your rejected, accept your null hypothesis. Okay. So that now you have to find out in. Okay. So now your calculated value is less than the table value. That's why you have to accept our null hypothesis for column. And next one, between row. So here 19.33, here 1.7. Here also your calculated value less than the table value. Again, the row wise also we have to accept our null hypothesis H0. So either one accept, either one reject na. So there is a significant difference between the row factor and column factor. But here both are you are accepting our null. There's no significant difference between the row factor and column factor. So that is our conclusion. There is no significant difference between the salesman and between the season so far as sales is concerned. Okay. So therefore, both are we are accepting our null hypothesis column as well as row. So that there is no significant difference between the column and row. So your column wise represents salesman, row wise represents seasons. There is no significant difference between the salesman and their season. Okay. So either one accept, another one is reject. So now your conclusion becomes there is a significant difference between the salesman and their sales. So this is two-way classification. So this procedure is clear?
Yes, sir.
Okay. So that's all. So correlation over, regression analysis over, then one-way classification over, two-way classification is over. Okay. So similarly, by practicing this problem, you are considering machine type. There are 4 kind of machines and workers, different workers, T2, 1, 2. So therefore, assignment differ with respect to mean productivity. Whether mean productivity is the same for the 4 different machine types. Okay. Actually, in that problem, we have 2 factors influencing machine and workers. So therefore, is there any significant difference between the machine and workers? So you have to do that one. Okay. Here also, most of the values are multiples of 40. Therefore, you have to simplify that value. Not only so that is your wish. If you fix 40 or 41, 42, 43, that is your wish. Okay. So if you are considering multiples of 10, subtraction is easy. That's why. So 40, if you are fixing your common origin is 40, easily you can subtract all the values. 44 minus 44, 46 minus 46, and that way you have to. So clearly, one more problem here also, salesman and season, that kind of problem. So you can do that. So only one factor, but look at this problem. In that problem, so we have 4 technicians. Only column wise we have to consider. So is there any significant difference between the among 4 technicians? So therefore only one factor. That's why we have to perform one-way classification. Okay. So this is the thing. So any other doubt in that unit? So, small corrections are there in that notes. So manually I have to correct it. So after that I have to upload that notes in your GCR.
Okay, sir.
Okay. So no doubt now I will take attendance today.
Okay, sir.
Number 1 for Arvind Shrath. Number
Sir?
1.
Yes, sir.
Presenter?
Yes.
Yeah. Number 2, Mandida Roy.
Present, sir.
Okay.
Present, sir.
Then, yeah. Then, number 3.
Present, sir.
Okay. 4.
Present, sir.
Aisha.
Present, sir.
Okay. 6. Aditya.
Present, sir.
Okay. Next one, 7.
Present,
Soumya.
sir. Present, sir.
8.
Present, sir.
9.
Present, sir.
Okay. Number 10.
Present, sir.
Number 10. Okay. 11.
Present, sir.
Okay. 12. Number 12. 12 absent. Then 13. Vinod Kumar.
Present, sir. Yes, sir.
Okay. Okay. And 15. 15. 15 absent. Okay. Then 16. 16.
Present,
Sir.
sir.
Okay. 17.
Present, sir.
18.
Present, sir.
19.
Present, sir.
Okay. 20. 20. 20 absent. Then 21.
Present, sir.
Okay. Then 22.
Present, sir.
22. Okay. 23. 23 absent. 24. 24. Ritvik. 24. Ritvik absent. Okay. 25.
Present, sir.
Okay. 26.
Present, sir.
27.
Present, sir.
28. 28 absent. 29.
Present, sir.
30. 30 absent. Vaishnavi absent. 31. Aparna.
Present, sir. Present, sir.
32.
Present, sir.
33.
Present, sir.
Yeah, okay. Then 34. 34.
Present, sir.
35. Ayush Sharma. 35. Absent. Okay. 36.
Present, sir.
38. Muhammad Asif Khan. 38. Absent. Okay. 39. 39. Anisetti Purna Chandra. Absent. Okay. 40. Pradeep Jain.
Present,
Pradeep.
sir.
40.
Yes, sir. Yes, sir.
42.
The 41 present.
Okay, okay. 42. 42 absent. Apur Kumar. Okay. 43.
Present, sir.
Okay. 44. Rogan.
Present, sir.
45. 45. Arunesh. Absent. 46. Vishwa Muthuvel. Absent. 48. Kirti absent. Amma. Kirti absent. Okay. Next one. 49. Missy Jain.
Present, sir.
Okay. And 50.
Sir,
Shukir.
present, sir.
Okay. Okay, ba. Thank you, students. So we'll see you in the next class. Okay.
32 and 30 are present, sir. They have written in the chat box. And 38 and 48.
1 minute. I will check it here.
Yes, sir.
32, 38, and 48. Okay.
30 also, sir.
1 minute. 1 minute. Ma. One by one I can tell. 32% and 38%. 48.
Yes,
Sir,
sir.
30
And
is also
30.
messaged.
Tell me, ma. 30.
Yes, sir.
Okay.
Okay, sir.
Okay, ba. Okay, ba. So fourth unit over, pa. Okay. 4 over.
Okay, sir.
Next class onwards, we got to take an unit. Okay. So thank you, students. We'll see you in the next class.
Thank
Thank
you,
you,
sir.
sir.
Thank you.
sir.
Thank you.
Thank you, sir.
Thank you.